Solving equations when x or an other variable is an exponent. First, how would you solve 2 times x cubed equals 64? Well, 2 times x cubed equals 64. What's the first step? Divide by 2. And then what's the inverse of x cubed? Well, cube root. You do the inverse to one side, you got to do it to the other side, and you get x equals 2. Now, this is an algebra problem. You notice where x is. It's not the exponent, it's the base. And, you know, algebra, x is always in the base location. Let's look at this problem. Okay, how would you solve 2 times 3 to the x power equals 162? Well, the obvious thing is get rid of the 2. We want to get the base and the exponent by itself. So we got the base and the exponent isolated. Now you got to say, well, how am I going to detach that x that's hanging on that top right corner? You can't divide because that's not the inverse there, okay? It doesn't say 3 times x, it says 3 to the x. There's a difference there, all right? One is a base and one is an exponent. This is an exponent. So what's the opposite of an exponential function or inverse of the exponential function? Well, the answer is log, okay? And every log has a base, and you use the base that happens to be attached to that x or that variable. In this case, it's 3. So we're going to do log base 3 of 3 to the x equals log base 3 of 81. You take the log on both sides, right? Now, if you look at the left side, it says, what do you raise 3 to get 3 to the x? Well, what would I raise 3 to get 3 to the x? Well, I believe that would be an x. Okay? And so see how these cancel out? Just like we did exponentiation, they canceled out. Now, we could make up a word, logation, I guess, and they cancel out. So if you like that logation word, you're permitted to use it. Okay, now, I don't think it's a real word. On this side, we have log base 3 of 81. Now, let's pretend we don't know what that answer is. And we could use change of base. And the change of base is log of the number over log of the base. I barely got that in there. Okay? So we're going to do that, and so we end up with 4. Okay. And then let's go back and check. What's 3 to the 4th power? Well, 3 squared is 9, so 3 squared times 3 squared is going to be 3 to the 4th, and that's 9 times 9, so that's 81, and 2 times 81 is 162. Now, let's look at this one. Again, x is not in the base, it's in the exponent, okay? And it has a plus 2, but that's not a real big deal, as you will see. So, what you want to do is, what's the inverse of the exponent? The log. So we're going to do log base 3 on both sides. Okay, what you do to one side, you do to the other side. This cancels out. So you're just going to have x plus 2 log base 3 of 12. Now, you can't do that one in your head. So, how could we get this? Well, we can use change of base. Now, you could do the minus 2, then do change of base, but I think it's more likely to mess up on a calculator. So let's do the change of base first. All right? So it's log of 12 over log of 3. And round it off. I always, you know, the problems you guys are going to get, probably going to say 3 decimal places, so I'd go 4. And then all you have to do is get x. Uh-oh, I ran out of screen. I got to pull this up. There you go. All right. So you got to subtract 2 from both sides, and you get 2.619. And then you check, is 3 to the 2.2619 equal to 12? Remember, that's x, and you got to put it up there in the exponent, and you have to add 2. So it's going to be really 3 to the 2.2619. That should be approximately 12. You can check that on your calculator. You should be doing that on quizzes and tests. All right. If you have a calculator, you should check that to see if it makes sense. All right. That's it.